All right. Hello, everyone, and welcome back to Comp 2160, Programming Practices. It is our last class today. Hooray, yes. I hope you're all doing okay. I've got exactly one thing I want to do today, and that is, by the end of today's lecture, I want you to know more about the final exam. That's what I want you to be able to do today, is know more about the final exam. We'll have some space for questions about the assignment after I've talked a little bit about the final exam. I'll have some space for questions about the final exam. Then what I want to spend some time doing is kind of just going through all of the learning outcomes in the course, kind of doing like sort of a review and sort of what I've been doing for those weekly roundup things, but for the whole course instead of just 1 week at a time. I'm not going to do one of those weekly roundup things for this week because I'm going to do it like right now. We're going to do it in class together as opposed to being something separate on Friday. Before I get to any of that, I've had this question a couple times, so I want to make sure that everybody has the same information. The assignment due date that we hover over here, it says, but Handon will accept submissions until Friday, June 14th at 4 p.m. It will accept submissions until Friday, June 14th at 4 p.m. And I'm not going to be giving anything to graders before then. I'm not going to look at the Handon folder until after that, and I'm not going to look at when things were submitted until then. If Handon accepts your submission, and it will accept submissions up until 4 p.m. tomorrow, I have received your submission. Handon will reject your submission if you've handed it in after that, but you've got until 4 p.m. tomorrow to submit the assignment. I'll leave questions for the assignment a little bit later, but what I want to do right now is just spend a little bit of time talking about the final exam. So the final exam is going to be a comprehensive final exam. So this is all stated learning outcomes are eligible to be assessed. So everything that we've done in this course is eligible to be assessed. Although emphasis will be on the second half of the course because you haven't been assessed at all on the second half of the course. But you know, there's stuff that we did in the first half that you may be explicitly assessed on again. But there's also stuff in the first half of the course that you kind of just have to know to be able to do the stuff that's in the second half of the course. So you may also be implicitly reassessed on things from the first half of the course. As with the term test, seating is going to be assigned. I will send you an email before Wednesday next week with your paper number and your seat number. The final exam schedule has room assignments now. We are located in room 100 Fletcher Argue. So on Thursday morning next week, we are going to be meeting in 100 Fletcher Argue. I will put on the screen in the room, kind of like what I did in this classroom, I'll put a map of where seats are to give you an approximate idea of where your paper is going to be. But names are going to be printed on the papers in the same way that they were for the term test. So when you get to a paper, make sure it's got your name on it, and that's the paper that you should write. If you're writing somewhere else, if you've made arrangements to write in other locations, then I will make sure that the paper that's assigned to you gets to you. But for everybody that's writing with us in 100 Fletcher Argue, I'll put that thing up on the screen so that you can see where you're supposed to sit. And you'll get an email from me next week before Wednesday with what your seat assignment is going to be. This is a 2-hour exam, so you're going to have 120 minutes to write it. The structure is overall going to be similar to the term test. So there will be some multiple choice questions. There's going to be some short answer questions, and there's going to be some programming related questions. Programming question is the big question. This will be where the bulk of the points are for the final exam. You can assume that this is going to be the one that has the most points attached to it on the final exam. The question that I'm going to ask you to do is implement an ADT. I will give you an interface, and I will expect you to implement that abstract data type. The data structures that you're using for implementing this ADT are going to be no more complicated than linked list structures. Linked lists have been our best friends this course. They will continue to be our best friends on the final exam. So you can expect to get an interface for an ADT and then expect to be implementing it using something like a linked data structure, like a linked list. The abstract data types that you can expect to see are things that you have seen in up to 2140 this term, this offering. And I'm going to cap that at, I believe that hash tables was the most recently covered thing in 2140, so that's where it stops for abstract data types. That's the type of abstract data types that you can expect to see from 2140. If you're thinking about wanting to do some practice with abstract data types in C, look back at what you've done in Comp 2140, take those interfaces and just try to implement those data structures and abstract data types. Even all the way back to 1020. So thinking about things like queues. You may have seen a queue in Comp 1020. You may have probably saw a queue in Comp 2140. You've seen stacks. You've done stacks on an assignment. You may want to just re-implement that on paper. Just see if you can do it without a compiler beside you. You've seen, I mean, the zone-based memory manager is an ADT, but you can safely assume I will not ask you to implement a zone-based memory manager on the final exam. That's not the ADT I'm going to give you. When you're implementing this ADT, you must apply the concepts of design by contract. So I will explicitly be looking for you to write assertions that are encoding your assumptions about preconditions, that are encoding your assumptions about postconditions, that are encoding assumptions that you have about the data structure that you're using in the form of an invariant. You must apply defensive programming, so you must make sure that you are checking for null with conditional statements on top of using DBC to enforce those sorts of things. You're going to have to write test cases. However, I will not be expecting you to write code for test cases. Writing that test case structure is tedious and painful and a waste of your wrists, and I don't want you to have to spend a lot of time writing these stupid conditional statements and writing counters and stuff on an exam where I really want to see things like design by contract and defensive programming. So what I'm looking for test cases here for implement an ADT is I want you to come up with test cases. What is the input and what is the expected output? What functions would I call to verify that, but not necessarily writing this big structure of conditional statements and counting things to see if the value is what you're expecting it to be. I'm looking for you to describe general case test cases. I'm looking for you to describe edge case test cases, the functions that you would call, and how or what that test case that you're describing is going to find out whether or not it works correctly, works the way that you're expecting it to. Are there any questions about the final exam? Yeah. Do I have it made already? No, I'm not that good. I have written some questions. I already know what ADT I'm going to use, but like this question kind of writes itself because I will just give you the ADT and then I'm going to be doing exactly what I say there. I want to see that you're using design by contract and defensive programming and that you're able to come up with test cases for that. So that question kind of just writes itself. Yeah. 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 It will be one single programming question, but in the sense that it's implement an ADT, it's going to be a fairly big one. There's going to be a lot of functions that you're going to have to implement. Yeah. For the test cases, I'm not expecting you to write C code. I'm expecting you to tell me about what the input is, what the expected output is, what functions you're testing, what behavior you're testing. I mean, I am going to write questions like this in a similar way to the way I did on the term test where I said write 2 or write 4, and then I'm going to stop at 4. Whatever comes after that, I'm not going to evaluate anymore. It's not going to be try to be exhaustive and comprehensive. You only have 2 hours in this exam. You can't be exhaustive and comprehensive. I just want to see that you're able to come up with reasonable test cases for the data structure that you've implemented for that ADT. Yeah.
When you said programs, the bulk points, what percentage is that bulk approximately? 50?
I'm going to say approximately 50% of the exam will be this ADT. Subject to change, but like ballpark plus or minus 10%, yes. Any other questions? Yeah.
What if you're writing code and you insert a line somewhere?
That's a fair question. What if you're writing code and you want to insert a line somewhere? My first answer is to use a pencil as opposed to a pen. That's not a good answer because you still have to then erase a bunch of stuff. I am not a C compiler. I understand when you do things like write a line of code at the bottom of a paper and then draw an arrow and say, put it here, please. I understand things like that, where a C compiler doesn't. I am not a C compiler. I'm not going to compile your code. It would be a massive waste of my time to type everything out and see if it actually compiles. That's not something I'm going to be doing. If you're in a state where you feel like you need to re-add something and you've written a full page of stuff, then make it clear to me what you're trying to change so that I can understand what you're doing. Yeah. Yeah.
Can you like explicitly write like my computer? Like there are a lot of ways you can do trees. It's also
So up to what Comp 2140 this term is doing. And what Comp 2140 this term is up to is hash tables. Those would be reasonable things to practice on, yes. I'm not going to promise that it's going to be any of those, but those would be reasonable things to practice. If you want to spend some time practicing this and you want me to give you informal feedback about what you have done, I'm not going to grade the work that you give me, but if you want to like type something out or write it out and send it to me as a PDF or an image or something, I would be happy to give you informal feedback about your practice. Yeah. Any other questions? Okay. If you do have questions about the final exam, I would very strongly prefer that you ask those questions on the course discussion forum as opposed to by email or in person, because I want to make sure that everyone in the course has access to the same information. Whether they're sitting in this room or whether they're watching there or just looking at the forums, I want to make sure that everyone has the ability to access that information. So if you have questions about the structure of the final exam, please ask those on the course discussion forum. So with that, I think I'm going to reverse the order of these things right now. Are there any remaining questions about the assignment that you are working on right now, other than the due date that's on the assignment document? Handin will accept submissions until 4 p.m. tomorrow. If it's submitted, if it says happy noises like successfully submitted, then it has been accepted. Are there any questions about the assignment? Yeah. I have given you a test case that looks exactly like that, yes. I think it's safe to assume that my test suite is comprehensive. I'm pretty sure I've tested every possible invalid input for all of the functions. I believe that I have, but if you think I've missed something, then you should add something to your own test suite. Oh, like for the exam or for the assignment? I'm expecting you to come up with test cases that represent like what you understand about your own implementation. So I have implemented a bunch of tests that are like, this is what the interface says should happen, but you know more about your internal data structure than I do because you've actually written your internal data structure. So I've tried to make sure that I'm doing things like, I want to make sure that if I delete something from the front of the allocation, the blocks that have been allocated, that first fit happens there. You may want to do things like make sure that you're getting stuff at the end. If I delete the last item in the list, then I'm going to make sure that the next thing I get is going to be put at the end of the list as opposed to at the front or anywhere else. Yeah. So, I mean, you can look at my tests for inspiration, but they should really be more tailored to the implementation that you've got. Yeah. You can also spend 4 or 5 hours making a game in curses if you want. That would be another good way to do this. Yeah. Assert statements should be both in the functions and in invariants for the implementation of zones. You shouldn't use assert at all in your tests, though. Yeah, the preconditions, like a lot of preconditions will include things like the data structure that's coming in is a valid data structure. So you're going to call your invariant as part of a precondition. If you're making changes to the data structure, a postcondition is that it's still valid after you've made those changes. But there are other preconditions like, for example, with make zone, you can pass 0 to that, but you shouldn't be able to. You don't want to make a zone that has 0 bytes allocated to it. So that's a precondition that doesn't fit into the invariant function. Yeah. Yeah.
Said that your test cases are exhaustive. By that, are you implying that you should be including some things from your test case, like 3, or even like raw input and null input?
When I say exhaustive, I specifically mean that test 3. Like I believe that I have exhaustively tested all invalid inputs of the form null and of the form 0. Your test cases shouldn't be testing invalid data. That's not what I'm interested in. Yeah. Can you steal my require function? Yes, yes. I'm sorry that I never said this in class, but somebody asked this question on the discussion forum. I think that they asked it here. You all need to come up with better subjects for your questions for the forum because A3Q1 it's fine, but it's not very searchable. Yeah. I think it's here. Maybe it's not here. No, it's here, using solution structure. So this one actually is a reasonable request. Can we use the code from stack test solution that was posted because it looks cleaner and more readable? Yes, absolutely. You can use that structure if you want to. When I'm doing misconduct checking, I'm not looking at that file. I don't care about the test structure. If you've used mine, I'm giving you permission to use mine. Yeah. So yeah, use require, use the whole thing if you want. Yeah. Yeah. Yes. Test 3 should not segmentation fault. It should run to completion. Yeah. If it's segmentation faults, then that usually means that you have an assertion, which is great, but you're not checking with conditional statement. Yeah. Yeah. Any other questions about A3? I changed the end date for the discussion forums just before this class, thank you, to be tomorrow and not today. So you can keep asking questions on the discussion forum tomorrow if you want. That will be available up until 3:30 tomorrow. Yeah, all right. The other thing I want to say about this is that I will publish my sample solution, and then I'll post a video on the course webpage of me like excuse me, stepping through my implementation, kind of like what we did in class for the stacking implementation, so you have an idea of what I did before you get to the final exam. Yeah. It's a de facto standard to put the name of the header file. That's just my mistake. As long as I've used regions in the second statement of define, did I? Yeah, if I've used the same string in both of them, then it's the same thing. Then it's fine. I meant to put zones H there if I didn't put zones H there, but yeah, that's a typo on my part. So if I go to, so as long as these two things at the top are identical, then the header guard is going to work the way that you're expecting it to work. Yeah. This should be zones H, and this should be zones H, but the behavior is going to be the same, whether it's zones or whatever, or like underscore Pikachu, as long as the two are identical, it's going to prevent multiple inclusion. So this would do the same thing as that, yeah. Any other questions? We're all good? Okay. So what I'd like to do then is I'd like to take a look at all of the learning outcomes for the course and talk a little bit about each of those learning outcomes. I'm not going to be looking at this in our course schedule, but rather I'm going to go to the main computer science homepage. I'm going to go to course offerings here, and then I'm going to go to Comp 2160. I think I mentioned this page earlier in the term, but this is a page that has course descriptions and learning outcomes for most or all of our courses in computer science. So if you're wondering what a course covers in terms of material, this is a good place to look. I'm going to make this a little bit bigger. And then what I'm going to do is kind of start at the top with these learning outcomes and go through. So one of the major goals that we've had in this course is to use this idea of design by contract. The learning outcomes that are related to this are all about abstract data types, preconditions, postconditions, and invariants. The very first learning outcome here, define the interface to an abstract data type. We didn't really do that in this course. We didn't really do that in this course because I've always given you the header file for the abstract data types that we're working with. But I believe that it's reasonable. I'm not going to assess you on this, but I believe that it's reasonable for you to look at Q data structure and know what functions you should put into the interface now. A Q abstract data type has create, destroy, push, and oh, it's like Q and DQ, deq, yeah. It's got those 4 operations. That's the abstract data type interface for something like a Q. I am not going to assess you on this. On the final exam, I will give you the header file. Here's the interface. Implement this as a data structure, but I believe that you should be able to do that. You will do this extensively in Comp 2150. You will start seeing it in other courses as well once you get past this one. The next one, define the implementation of an ADT using a private data structure. This one I have assessed you on once in assignment 2. I am assessing you on it right now in assignment 3, and I will assess you on it on the final exam. I will give you an interface, and I will expect you to implement this using a private data structure. When I say private data structure here, I'm also adding that keyword static to this idea of private data structure. If you are writing functions that are not exposed in the interface for the abstract data type that I'm giving you, they should be marked static. If you have file scope variables that are not part of the interface, they should be marked static. I should not be able to know anything about the implementation of your ADT other than the interface that I have in that .h file that has been provided to me and that I will provide to you for the final exam. Define the pre and post conditions for a routine. So what I'm looking for here is kind of what you saw on the term test. I'm going to give you an interface to an ADT, but I'm not going to tell you what all of the pre and post conditions are. I'm not going to write these all out this time. I'm going to expect you to identify what those things are. I asked you to do this on the term test, both in the form of like write them out in plain English, but then also write them as assertions. On the final exam, I'm looking more for you to just go directly to assertions as opposed to writing them out in plain English. Define the invariants that encapsulate the valid states of an ADT. So similar to pre and post conditions, you're going to have assumptions about this. I'm going to expect you to write a function that is an invariant for the data structure that you're implementing. And then finally, use preconditions, postconditions, and invariants to validate the runtime behavior of an ADT being used in application. So I'm expecting you to be able to not just define them, but also use them with assert statements to enforce those assumptions at runtime with when the code is running on a machine. Any questions about design by contract? Okay, yeah. Yes. So like I said, this time I'm going to expect you to just go directly to writing assert statements in the functions that you're implementing for implementing the ADT. I'm not going to ask you necessarily to use plain English to describe what those things are. I'm just going to do the assessment directly on assert statements that you're writing down. The next block here is testing. And what I'm expecting you to be able to do is explain the purpose of testing code. So what are we trying to accomplish by doing all of this testing? The short of this is we're trying to make sure that the code does what it says it's supposed to do. We're trying to do this in an automated way as opposed to, and that's learning outcome 6 here, explain the purpose of automated testing. We're trying to do this in an automated way as opposed to a manual way because it's kind of tedious and painful to sit down and just hand type in all of those different test cases that we come up with. Really the most important things that I'm looking for to assess you on for the final exam are these 2 outcomes, learning outcome 3 and 4. Learning outcome 2 is list classifications of test data, general, edge, and leak. I'm not going to ask that question on the final exam. That's something that you can very quickly look up. That's not a skill that I want to assess, so that's not something I'm going to ask. But learning outcome 3 and 4, these are ones that I am going to assess on the final exam. Create general case test data, inputs and expected outputs for an ADT. Create edge case test data, inputs and expected outputs for an ADT. So I am going to expect you to create edge case and general case test data. But I am not going to assess you on learning outcome 7, implement a test harness that automates the testing of an ADT. You're doing this in this assignment right now. It is painful and it is tedious, and I don't want you to have to write all of that stuff down. So I'm not going to be asking you to implement a test harness. My interest is in creating these test case test data. I want to see what you are generating for those to make sure that they are actually evaluating the behavior that's expected for the ADT that you are implementing. Any questions about that? Yeah. Profiling. Profiling is more part of this learning outcome right here than it is for testing. You can use profilers to help you with things. So like, for example, Valgrind can help you do memory leak tests, but I'd classify it more as a profiler than memory leak testing. I'll also say, so specifically about memory leak testing, there is no learning outcome here that's create test data to evaluate memory leaks. I'm not going to ask you to run Valgrind on the on the final exam. Yeah. I'm sorry I interrupted you. What was it? Okay. No, I'm not going to ask you to use a profiler on the final exam. Any other questions about testing? Okay. All right. Programming practices. So the first learning outcome here is recognize potentially risky programming techniques and how they differ in different high-level languages. This is a learning outcome that we haven't, I mean, we did state this explicitly a couple of times, but we didn't really talk about just this. One of the ways that we're doing this learning outcome in this course is we've learned C. That's the main thing that we did to identify risky programming practices, is that we have learned the C programming language. And the specific things that I'm going to point at here are things like, we don't have array index out of bounds exception in C. And that leads to all sorts of neat stuff, like if I use a function like scanf to read input from the command line, it's possible to overwrite buffers that are not part of the buffer that I have passed to scanf. This is a risky programming technique. This results from not having things like bounds checking, array index out of bounds exception. This differs in different high-level programming languages. In Java and Python, you get out of bounds errors. So I believe it's index error in Python and array index out of bounds exception in Java. These different high-level programming languages help make sure that you cannot even have those kinds of situations as we're able to do in C, because they enforce these things. The next learning outcome, write safe code in a programming language that makes it difficult to write safe code. And then apply good programming techniques to produce readable and modifiable code in a programming language that makes it easy to write unreadable code. I'm going to put these two things together. For this first one, write safe code in a programming language that makes it difficult to write safe code, I'm looking for things like, when you're passing arrays to functions, you must pass the size of the array to that function, because there is no array index out of bounds exception in C. We cannot do array index out of bounds exception. I'm thinking about things like, when you are asserting that something is not null, that you have a conditional statement that checks to see that it's not null, so that when assertions are turned off, that you will not crash with a segmentation fault when the code is run without those assertions turned on. Related to that is apply good programming techniques. I'm going to call those two things good programming techniques, but then this is also things like making sure that you're consistently using braces. Make sure you put braces on the correct line, or consistently put them on the same line as opposed to all over the place. Make sure that you're thinking about things like, I want to implement this as a separate function as opposed to being in line with the thing that I've got. Learning outcome 4 here, divide code from complex projects into higher level modules for separate development and compilation. This one is going to be related to, I'm going to scroll down here for just a second. This learning outcome is related to build and execute programs from a command line environment. For this one, specifically for compilation, I would expect you to be able to compile multiple files together on the command line. And I would expect you to be able to compile a .o file and then compile that link it to another C file. You've done this a lot. We've migrated to make files, but I'm still expecting you to be able to write simple commands that will compile code that are separate files for compilation. Divide code from a complex project into higher level modules. We didn't really do that in this course. I did the division for you. I gave you these header files, and then I said that you must implement this. And it was kind of like its own standalone unit. And then I said separately, you need to implement this main.c. We did it in the mechanical sense. I told you what to do and you did it. So I'm not going to be expecting you on the term test to be like, well, here's a fully fledged C program, break it into different pieces. I'm not going to ask you to do that. Describe the benefits of modularity and use simple metrics to specify the degree of modular independence, such as coupling and cohesion. In class related to this, we did two things. One was we looked at abstract pictures and we tried to decide how cohesive they were or how much coupling was in those abstract pictures. Because they were abstract pictures, there was a lot of kind of like flexibility. Different people can think different things, but that wasn't really the point of the exercise. We then looked at coupling and cohesion specifically with code examples. So we looked at game.c and we looked at that search.java program. I would expect you to be able to tell me about how much cohesion there is in a short code sample. I cannot put 500 lines of C code in the final exam. I can't. That would kill way too many trees. And I'm not going to put 500 lines of C code. But I probably will put a short fragment of code, maybe C, maybe Java, and ask you questions about coupling and cohesion with that specific code segment. And I'd expect you to be able to tell me whether this code sample has high cohesion or low cohesion, why it has high or low cohesion, and I'd expect you to tell me about how much coupling it has with some specific other implementation. So whether it's high or low or tight or loose coupling. The last part here, given an existing solution, identify and explain where the use of appropriate data structures, algorithms, and/or techniques such as caching and lookup tables provide better paths to optimization than low-level code. I'm not going to ask you to run a profiler. I'm not going to give you the results of a profiler and ask you to interpret those results. I'm not going to do anything like that. At most, what I would do is give you some example with code that uses specific data structures and ask you to tell me if it's possible to change the data structure and what you might do. Again, related to what we did in class. I showed you an example of code that uses an array list, and then we switched it to hash set, and it worked way faster. Any questions so far? Please stop me if you've got any questions about anything. Yeah.
Consider an array list.
An array list is a data structure. So we have abstract data type, and we have a data structure. An abstract data type is really just a series of operations that you can perform on something. It's just some abstraction. It does not say anything about how it's implemented. A data structure is the actual implementation of that thing. So a list can be an abstract data type. An array list is a data structure. A list has operations. I want to be able to create it. I want to add or insert things in specific places. I want to delete things from specific places. I want to destroy this thing. An array list implements that interface with an array. And then nodes. There are nodes that are attached to that. A hash set is an implementation of a set data structure. Sets are data structures where you can add things to it and then test for the presence of those objects. You can ask questions, is this in the set or not? That's pretty much it. You might be able to remove things from a set, but it's all about just asking, is this thing in the set or is it not in the set? Just a binary yes or no question. You can implement that with a hash table. The hash table is the data structure. The set is the ADT. Yeah. So our data structure in this course, our beloved data structure in this course is the linked list. Yes, that is the data structure that we have used extensively in this course. And that will just keep haunting you for the rest of your life. Yes. Did you have a question? Okay. I believe that it's reasonable for me to assume that you know how arrays work at this point. Yeah. I believe that it's reasonable for me to assume that you know how lists work and linked lists specifically work. Those things might get combined, but I mean, that's a reasonable thing to expect. Yeah. Any other questions about this so far? We're doing okay? Okay. Yeah. Yes, yes, please. How do you practice for questions? So This one, a good exercise here would be to just start thinking about, like even looking back at the assignments that you've done, is this code actually cohesive or not? I will give you an example of that. The zones interface as it is not cohesive. It has like medium-high cohesion, but not high cohesion. It has medium-high cohesion because of that z-dump function specifically, the one where you're printing stuff out. A zone shouldn't be responsible for printing itself. It shouldn't have that responsibility. It should be responsible for managing memory, and that's it. In terms of coupling, if I depend on zones.h, then I have coupling with zone as a memory manager, but I'm not depending on how you're implementing it with a linked list. If I was able to ask questions like, what's the head of the list in the zone? Then I have high and tight coupling with that implementation of the zone. So what I would suggest you do to practice this is go back through your assignments, not even this course, go back through your 1020 stuff, go back through your 1010 stuff and start to think about these questions again. Was the code that I wrote in 1020 for my last assignment, was that cohesive or not? And then be able to say yes or no and why it was or was not cohesive. I'm a lot more interested in why it's not cohesive than why it is cohesive. It's cohesive because it does one thing and it does it well. That's the answer. It's not cohesive because that's the one that I'm much more interested in. Yes. Yes. In terms of write safe code, in terms of apply good programming techniques, in terms of define invariants, preconditions, and postconditions, that is practice programming. I would suggest that you practice programming on paper, but I know that's kind of painful. Minimally think about it by programming in an editor. You don't even have to write code that compiles. It can just be thinking about it and making sure that you have a good sense of what that stuff is. Yeah. Okay. Memory and pointers, write, test, and debug programs in a high-level language that exposes low-level details of data types and memory addresses. I am not going to assess you about that on the final exam, except for the part that says write. I'm going to expect you to write programs that expose low-level details of data types and memory addresses in the sense that I will be asking you to write a C program. That's the part of this learning outcome that I'm assessing you on. I will not be necessarily asking you questions about like, I want you to do a bunch of arithmetic on memory addresses. I will be asking you to implement a linked list. It will have pointers in it. It will 100% have pointers in it, but I'm not going to be asking you to do arithmetic on pointers. I don't really care that much about that. You're doing that in assignment 3 right now. Describe the concepts of in-application memory management, such as first fit memory allocation, the runtime stack and the heap, and garbage collection. In this offering of the course, we did not do garbage collection at all. You will not be assessed on garbage collection at all on this final exam. You should be able to describe how the first fit memory allocation policy works. You should be able to apply the first fit memory allocation policy given some example situation. Here is memory, here is how much I am requesting, where does it go? You should be able to do that visually on a final exam for this course. In terms of the runtime stack and the heap, I already asked you questions about the runtime stack on the term test, and I am unlikely to ask those same questions again. I didn't ask you questions about the heap on the term test. I didn't ask you questions necessarily about what the layout of memory looks like for a process on the Linux operating environment. I didn't ask you questions about what the address space layout looks like for a running program. I may ask you those questions. This is just kind of like remember stuff for the most part. The first fit memory allocation policy, this one is apply. I'm looking for you to apply this first fit memory allocation policy. Implement a simple systems level solution to one of the in-application memory management techniques. This is assignment 3. You are doing this one right now. I will not assess you on this in the final exam. I'm not going to ask you to write zones on the final exam. I will not ask you to do that on the final exam. Use function pointers to parameterize behaviors. This is something that we did yesterday. Use function pointers to parameterize behaviors. I would expect you to be able to do things like declare a function pointer. I'd look for you to be able to do things like assign a value to a function pointer. I'd look for you to be able to do things like call a function pointer, call the function that's pointed at by a function pointer. That's the extent that I'd be looking at for stuff related to this learning outcome. For tools, build and execute programs from a command line environment. As I said, this one is tied with that learning outcome about modular code. I would expect you to be able to at least write down the commands that would be required to compile multiple files together using a C compiler. I'm not going to expect you to run programs in a command line environment because you won't have computers in front of you. I can't expect you to do that. Write code that takes advantage of its environment through simple command line options. So we actually did not do this at all. We did not do simple command line options for defining behavior. You won't be asked questions about that. I'm not going to ask you suddenly to start doing stuff with arguments to main because we never talked about it in this offering of the course. Yeah, I'm not going to ask you questions about that. The redirecting of standard input and output for file I/O, this part we did extensively. One thing that we actually didn't do at all in this course was use files. We didn't use file pointers. We didn't open files. We read a file with air quotes here. We read a file. The file was standard input. And we wrote to a file, and the file was standard output. We didn't do files, but we did redirect input and we did redirect output for file I/O. I asked you a question about this on the term test. You might see a question like this again. Be able to redirect things to standard input, be able to redirect things from standard output. I'd also expect you to be able to write some code that is able to do this. So read from standard input, be able to use that stdin, call functions like getChar and putChar. The next outcome here is use an automated build tool such as make, along with a predefined make file to build a complex project. Then the next one is define the build of their own project by modifying an existing make file. I will not assess you on make at all in the final exam. I can't promise that you're not going to see the word make, but it's not going to be in the context of make files. I'm not going to ask you about this. I'm not going to ask you about make at all. I will not ask you about make. Use a source level debugger such as LLDB to inspect program state and step through code line by line to determine the causes of errors in a program. I am not going to ask you to use LLDB on this final exam. You don't have a computer in front of you. I'm not going to ask you to use LLDB on this final exam to debug a program. That's it. That's our course. So like I said, there are a couple of things that we did not cover at all in this course. Command line options we did not cover at all in this offering of the course. And then the other one that we did not cover in the course was, I already forget. Garbage collection, thank you. We didn't do garbage collection in this course. So you don't have to worry about the words garbage collection, and you don't have to worry about the words command line options to define runtime behavior. We didn't do it in the course. I'm not going to ask questions about it. Are there any questions about anything right now? Yeah. The cutoff? Like the letter grade assignment. Letter grades, there are stated letter grade cutoffs. Letter grade cutoffs do often change. They will only go down. They won't ever go up. I'm not going to make an A+ 95, but I could make an A+ 92 potentially. But that's kind of a after everything is said and done operation. Yeah. Yeah. When do they come out? For assignment 2, they came out about 2 hours ago. Yeah. So if you haven't checked, take a look. Yeah. Also, I guess if when you're looking at your assessment, I'm not going to click through this right now, but there were a couple people that came to ask me questions about this where it would just like show this error when they tried to click on the rubric. And that's a terrible error message. UMLearn is a bad piece of software. I don't like it. It's fine. It's fine. I don't really like it though, because it does weird stuff like this, where it shows you this really cryptic error message that has nothing to do with the actual thing that it's trying to tell you about. If you receive an error message at all related to clicking on the rubric, you need to complete the blanket honesty declaration before you can see the comments that are left in the rubric. If you haven't completed the blanket honesty declaration, do so, and then you can see the feedback that you've gotten for the assignment. Yeah. UMLearn is software, yes. UMLearn is written in C#, which is maybe also why I don't care for it very much. I don't really care about C#. It is what it is. The company that makes this is called Desire to Learn. They have an office in Winnipeg. They hire co-op students fairly regularly. They have hired a lot of past co-op students. They're located mainly out of Southern Ontario somewhere though, and they provide software to most universities in Canada. Yeah, it's a fairly big company. I still don't like it. And it's not even necessarily their fault, because our university, now I'm ranting about this, I'm sorry. Desire to Learn's business model is that they sell pieces of a system, and universities can buy pieces of a system and then stitch them all together, and they get like this Frankenstein of a software system. And so Desire to Learn will like go through and they'll update a bunch of stuff, but our version of it doesn't get updated because our university has not paid for the license for the updated version yet. And so we're just stuck on old versions of some parts of it. So this is why you kind of see things like some of it changes sometimes, but other parts don't, because yes, that's my rant. The place where you might see bit manipulation related stuff, thank you for bringing that up. The place where you might see bit manipulation stuff is here. Write in a high-level language that exposes low-level details of data types and memory addresses. That's the one place where you might see this. I'm not personally that interested in assessing you on that. This is something that you might see if you're reading C code, but I'm not really super interested in seeing how well you can do bit manipulation and arithmetic on the final exam. Maybe. Yeah. Will there be a bonus question? Probably. I mean, it's not gonna be like a 50-point bonus question though. Like, this isn't gonna change a letter grade. Let me say that. Yeah. It picks a different animal at least. Yeah. I got some feedback about that. The feedback I got was from students. The feedback I got was, well, I saw a lot of great pictures. I saw a couple of Voltorbs. I saw a couple Sandshrews. I saw lots of really nice looking cats. I saw a lot of really terrible looking cats. Someone drew a dog because they didn't like that I'd picked cat. And of course, they'll still get the point for that because they drew something. Yes. But I would pick a different animal this time. Yes, I did. Yeah. Those were the terrible ones, though. Yeah. Any other questions about anything so far? Okay. If there are no other questions, I would like you to humor me for 5 minutes. What I want to show you is so yesterday we were looking at some of this this Game Boy Advance stuff. And what I want to show you today is doing input. So getting input from the Game Boy Advance. Remember last time that when I was talking about this, we're using these keywords unsigned and volatile here on lines 6 and 11, really specifically because these memory addresses here are well-known values. So When I'm writing VRAM here, I'm referring to video RAM. At this address, for the next, I think it's 24 kilobytes of space, this is a giant one-dimensional array that represents all the pixels on the screen. So the first, I think it's 240. So the first 240 elements are the top line of the output of the screen. The next 240 elements are the next line. The next 240 elements are the next line. The next 240 elements are the next line. So it's one long array that represents the whole thing, and each 240 element chunk of this short array is going to be one single pixel on the screen. The I/O RAM part here, this is going to be the things that we can use to write to configure how the system works. I'm going to pop open a link that I put into yesterday's lecture section. So again, if you're bored after this course, you can take a look at some of this stuff. And if you're interested in this GBA doc is a comprehensive set of documentation for the Game Boy Advance. And if I look at this memory section here, the part that I'm really interested in seeing is this memory mapped hardware registers. This describes what we're reading when we're working with that I/O RAM thing. The part that I am really interested in is this keypad input control registers part. So what this tells us is that at address 0x04000130, I can start to read bytes. And when I read those bytes, what I'm going to be reading from is a set of registers that indicate whether or not different buttons have been pushed on the system at the time that I have read the register. The Game Boy Advance uses something that's called active low. Active low here means that all of these are going to be ones when they are not currently pressed. When it becomes 0, that means that it is currently being pressed. I'm going to go over here, and I'm going to open up my emulator. I'm going to compile this code, and then I'm going to do mgba qt main.gba. And I'm going to pop open Tools, Game State Views, and then View Memory. I'm going to try open this again to see if it will give me something a little bit bigger. I may need to quit this entirely. This is okay. This is unreadable. This is completely unreadable. I'm going to quit this and try again. Everything is so big. Tools, okay, this is hopefully going to be a little bit more readable. Yes, this is more readable. Is this big enough for you at the back if you're following along? Okay. So what we're looking at right now is the contents of RAM for the emulator. So if this was the actual Game Boy system, this is what would be currently in memory right now. These are all the bits and bytes that would be currently in memory. This lets me choose from different regions of memory. So I can take a look at the video RAM, and the video RAM right now doesn't really have very much in it. This is a bit that I have set right now on the screen, and then the other ones, if we keep scrolling down here, and I don't go too fast, we should be able to see the RGB pixels that I put on the screen. But they're about halfway down. There they are. There are the 3 pixels that we put on the screen. So E0, 03, and 7C are the pixels that I put on the screen. If I go to memory mapped I/O here, we can see here at the top that those numbers are very rapidly changing. But the one that I'm really interested in taking a look at right now is if I go down here to 130. So this is that address that says this is the memory location where if you read this, you're going to find out what things are currently pressed on the system. I'm going to make this just a little bit smaller. Here, I'm going to make this really small. And I'm going to click in here, and you can't see what I'm doing, but I'm going to press up on my keyboard. And then I'm going to press down on my keyboard. And I'm going to press left on my keyboard. And I'm going to press right on my keyboard. And so if I read the values from this memory location, what this is showing me is that right now, FF says no buttons are pressed. They're all set to 1. If I press up on my keyboard, now one of those bits has been unset. Now it's 0. If I press down on my keyboard, one of those bits has been unset. It's now 0. If I press left on my keyboard, one of those bits has been set to 0. If I press right on my keyboard, one of those bits has been set to 0. I'm going to close my emulator, and I'm going to go back to 100% because this is just bananas. Can't even see the apply button anymore. I'm going to go back to 100% here, and I'm going to scroll down. And on line 26 here, I am reading the contents of that input. So IO RAM starts at that address 4 and then 7 zeros after it. And then at element 130 in that array, I can read that value, and that tells me what the current state of my buttons are. In this documentation, the ones that I'm interested in here are the top 4 bits of this byte. So these are this 2 groups of 4. This is one single byte. This is a single byte. This DULR, this is D-pad up, left, right, and down. So I want to see what the value of these top 4 bits are from this byte. To get the top 4 bits from the byte, I need to shift. I need to do that shift operator. I need to move those top 4 bits to the bottom. And then I'm doing an AND. I'm masking with just F for the last part. So this is 4 zeros followed by 4 ones. I want to turn off whatever these bits are. I don't care, and I don't want to see those bits. So I'm going to AND it with 0 to make sure that the top of that whole thing is going to be 0. So what I'm going to get back is just 4 bits that are set that can be any of these 4 things. And in my loop here, I've got this switch statement, and it's checking to see what the value of this these low 4 bits are. So 0x07, as an example, is 0000. That's the first 4 bits of the byte. And then 7 is 0111. So that means that we're pressing down right now. If I go back to my documentation here, down is this one right here. So when this is 0, that means that down is being pressed. After I go through and shift all of those 4 bits to the right so they're in the least significant position, and I mask off the top with that AND operator, I've turned all those off, then the resulting value when I'm pressing just the down key is 7. B here is going to be the same sort of idea, but for up. Up is this one right here. So the value that I'm inspecting here is 0000, 4 zeros, and 1011. So that middle spot there says that up is currently being pressed. D is going to be the left key here, and left is going to be this bit is unset. So it's 4 zeros and then 1101. And then right is E, and that's going to be 4 zeros and then 1110. So I'm checking each of these things, and then I'm also changing the state of video RAM based upon what I am seeing. And so in my emulator view now, what I've got, when I run this, if you look very closely at the top of this screen, right here at this spot at the top, as I press the buttons, it's impossible to see. It is so impossible to see. As I press the buttons here, it's changing the color of that thing based on the button that I'm currently pressing. This is, the way that I've written this is not going to work for things like if you're pressing A and the left button. This is only checking to see which one button at a time has been pressed. But you can start to think about how you might accomplish pressing the A button and the left button by looking at this bit string here and figuring that out. Yeah.
Do you think that if we made the game Snake on Game Boy, like using this, that is a solid project?
Do I think making Snake on a Game Boy would be an impressive co-op project? I personally think that would be an impressive project. I would say great job, and if I had a gold star to give you, I'd give it to you. For a co-op job, I think that, I mean, most hiring managers doing co-op are probably my age, so it's a reasonable bet to think that they played Game Boy when they were a kid. Yeah. I think it's an impressive project regardless. I do think it's an impressive project regardless. It's going to be really impressive if you're thinking about trying to get jobs that are doing low-level coding. If you're applying to places that are doing that. If you're doing web dev stuff, they're going to be more interested in seeing you do that on JavaScript than they are with Game Boy. They're still going to be impressed, but yeah. It's a sizable project to do something like that, yes. So if you are interested in this stuff, I'm constantly in the state of pitching other courses. If you are interested in that stuff, I'm going to recommend that you take a look at Comp 4560 ? No, 4550. This course. This is real-time systems. Real-time systems has a prerequisite of operating systems and computer organization. So this course and Comp 2280 lead into both 3430 and 3370. In this course, you're doing coding on an ARM processor, at least in the most recent offerings, with no operating system. You're kind of doing what we're doing here with this Game Boy setup. We're just coding directly to the hardware. We have to read the documentation that describes what the hardware looks like to be able to do that. Michael Zapp teaches this course a lot. And one of the things that he's been working on is making this little game on this platform. And it doesn't do much, but because I know what I know, I realize just how amazingly impressive it is. And students in his course were doing things like making Pac-Man on these tiny ARM devices. So kind of like what you're working with the Game Boy Advance. And again, because I know what I know, that's an amazingly impressive project to do. It doesn't look that impressive when you've got a screen that's this big and you're showing part of Pac-Man implemented on it, but yeah. This is going way beyond your question. Do I think it would be a cool project to show co-op employers? I think any project would be cool to show co-op employers, honestly. If you're willing to do something that you're kind of passionate about, I think that's the thing that they're really looking for, as opposed to like technical prowess. They want to see something that you're passionate about doing something, as opposed to how good you are at working in C or whatever. Again, except in the special circumstances of I'm specifically looking for system stuff, low-level system stuff. Then that is explicitly going to be both appealing to, I can do this low-level system stuff, and I'm interested in it. Yeah. Flashing colors. All right. When I said lower your expectations, I really did mean lower your expectations for this. All right. I think that that I've stood on my soapbox for long enough. If there are no other questions about the course material, then I think that I will just call it here. I'm grateful for you all coming to class all the time. This has been a very fast 6 weeks. I wish you the best of luck on the exam. I wish you the best of luck on what remains of the time that you have for your assignment. I wish you the best of luck in courses that you take after this course, and maybe I will see you again. That's it for me. So thank you all for coming out, and I'll see you on Thursday. Bye, everyone.